Welcome to The Explainer. Today, we are diving deep into the world of quantitative finance. It's this incredible, ambitious attempt to use the pure, clean logic of math and AI to predict something that's, well, famously unpredictable: the financial markets. You see, at the end of the day, markets aren't just a stream of numbers on a screen. They're a living, breathing reflection of us, of human behavior. It's a total battleground where cold, hard logic is constantly clashing with very raw, very human emotions like fear and greed. It is messy, it's dynamic, and it is fascinatingly human. And for decades, we've had this dream, right? The dream of taming that mess, to put it in a box, to model it, and maybe, just maybe, to predict it. And the tool of choice for this massive undertaking, mathematics. This is the very heart of what we call quantitative finance. So, what's the big idea here? What is the fundamental goal? Well, it's this incredibly elegant promise, the idea that we can impose some kind of order on all that chaos, that we can translate these wild market swings into clean, workable models. So these folks, the quantitative analysts, or quants as they're known, their main objective is to take human guesswork out of the equation as much as possible. They build these incredibly sophisticated, data-driven models for literally everything, from pricing complex derivatives to managing massive amounts of risk. The goal is to make financial decisions systematic, not emotional. And this brings us to a really crucial question. Is any model, no matter how complicated or how data-driven, ever truly neutral? Think about it. Every model is built on assumptions. So the critical part isn't just the final calculation. It's the choice someone made about what was important enough to calculate in the first place. Every single model reflects a choice. Okay, so let's start with the classics. Let's rewind a bit. These are the foundational models of finance, these perfect, elegant theories. They're beautifully constructed for sure, but maybe just a little brittle when they come face to face with the real world. Take the capital asset pricing model, CAPM for short. It's an absolute cornerstone of modern finance, and you know why? Because it's so simple and appealing. It gives you this clean little formula that basically says an asset's expected return is all tied up with how sensitive it is to the big market movements. We call that factor beta. Really, it's just asking, how jumpy is this stock compared to the whole market? It sounds so clean, right? So perfect. But here's the thing. What is that elegant formula built on? It's built on a set of assumptions about a perfect, frictionless world. So what happens when that perfect theory smacks right into our messy, imperfect reality? And this slide just lays it all out, plain as day. The model on the left, it imagines this perfect world filled with rational robots who all think alike and where trading is free. But the reality, over on the right, well, that's us. It's messy, we have biases, we have to pay fees, and some people know things that others don't. The model gives you a perfect answer, but for a world that simply doesn't exist. And this brings us to such a vital insight. The real risk isn't in using the model. The risk is when we blindly accept its output as the complete and total truth. This is such a powerful reminder that our own judgment, our own skepticism, is just as important as any calculation. All right, so now let's jump into the modern era. If those classic models were too rigid and simple, then AI, with its incredible ability to learn and adapt from data, seems like the perfect fix, right? But it comes with a whole new kind of danger, the peril of the black box. So a model like an LSTM, that stands for Long Short-Term Memory Network, is designed to be a kind of super historian for numbers. As you can see here, it chews through data over time. It uses these clever internal gates to decide what's important to remember and what to forget, and then it makes predictions. It is absolutely brilliant at finding subtle patterns in financial data that no human could ever hope to spot. But here is the catch. And it is a huge one, summed up perfectly by this Italian phrase, memory without understanding. These models can copy historical patterns with, just stunning accuracy, but they have zero idea why those patterns happened. The algorithm remembers everything, but it understands nothing. To really get our heads around the biggest risk here, let's use a simple analogy. Okay, picture an AI model as a student who has to study for a really, really important test. And all that historical market data, that's its study guide. But here's the thing. This student doesn't try to learn the underlying concepts. Oh no. Instead, it memorizes every single question and every single answer from that study guide perfectly. It even memorizes the typos and the random coffee stains on the pages. This is exactly what we call overfitting. The model learns all the random noise, not just the important signal.
So, you know what's coming next. Test day arrives. The real market, the future, doesn't ask the exact same questions that were on the study guide. The context has changed, the dynamics are totally new.
And because our model only memorized the past, it completely bombs the test. It fails. An overfit model can look incredibly accurate when you're training it, but it's dangerously unreliable when you actually let it loose in the real world. Why? Because it can't tell the difference between a real pattern and a random coincidence. Now, let's talk about what many consider the holy grail of quantitative finance, using all this math to build the so-called perfect portfolio. The foundational idea here is something called modern portfolio theory. It's basically a mathematical framework for creating optimal portfolios. Portfolios that are designed to give you the absolute highest possible return for whatever level of risk you're willing to take on. It's all about finding that mathematical sweet spot. And this brings us right back to our big theme, doesn't it? The math is flawless, the logic is perfect, but who is it actually optimizing for? Is it for a real, complex, sometimes irrational human being? Or is it for a simplified, theoretical, perfectly rational ideal of an investor? Because, let's be honest, when a model talks about investor preferences, it's not actually talking about you or me. It's talking about the simplified simulation you see on this slide. It assumes our goals are stable and that we're always perfectly rational. It completely ignores our real-world fears, our biases, our changing goals. The model isn't reflecting who we are, it's just imposing its own simplified version of us onto the problem. So let's try and tie all of this together. What is the one common thread that runs through both those classic rigid models and these new powerful AI approaches? It's all about what lies beyond the calculation. At the end of the day, every model is like a funnel. It's defined just as much by what it's forced to ignore, what gets left on the cutting room floor, as it is by what it chooses to include. The real evolution here isn't about going from simple math to super complex math. No, it's about getting smarter about what we choose to measure in the first place. And that leaves us with one final, really important thought to consider. As algorithms become more and more powerful, as they get embedded deeper into financial decision-making, we have to ask ourselves, in a world that's increasingly run by calculations, what is the real, lasting value of our very human ability to question, to be skeptical, and to doubt?